and I'll give you
Thank you.
to you.
All
Okay.
right.
This is Hewitt Plunkett. He's a junior in biochemistry, and he's working with Dr. Kerry Mauck in the Department of Entomology. He is double majoring in entomology, and he has conducted research in Dr. Mauck's lab since fall 2022. He is the secretary of the Natural History Museum Club, and he plans to get some patient care experience as an EMT this summer. And his talk is titled Investigating Thyme Essential Oil and Its Use as an Organic Acaricide. Go ahead.
Cool. Hi, everybody. I'm Hewitt. Savannah introduced me a little bit, but yeah, I'm a third year trying to double major in biochem and entomology. And so this project is about investigating thyme oil, and it's kind of preliminary research. We're not actually going to be using it on mites yet, but we're going to be looking into a little bit more about its volatiles, which are chemicals that like turn into gas easily. So we're going to see if thyme oil turns into useful gas stuff. Cool. So chickens are extremely important agricultural resources. They're all over the world. They produce both meat and eggs, which can be eaten. Eggs alone are one of the most readily digestible sources of protein for humans, and they're a complete source of protein, which means they have all 9 essential amino acids we can't make ourselves. So there are also 60 billion chickens raised just for meat, and 380 million for eggs. And that was in 2018 and 2022. And so chickens are obviously very important for food, but what do they have to do with this project? Well, we're looking at a major pest of the domestic chicken known as the northern fowl mite. Is The scientific name is Ornithonyssus sylviarum. It's a major poultry pest in the U.S., and it causes chickens to become stressed, anemic, and to lay fewer eggs. So there's one other major mite pest of chickens, and that is the red poultry mite. But the red poultry mite's bigger, it lives a little bit longer, and it likes warmer weather, and that's not what we're going to be talking about today. So the northern fowl mite is actually able to bite people, but it can't use human blood to reproduce. It actually needs chicken blood, and they're obligate parasites, and they live their whole life on the chicken, usually until it gets very cramped on the chicken when there's a ton of them. So at high population densities, they begin to fall off and look for other chickens to host on. But you can sometimes find them on the chicken's eggs or like around where the chickens are. And that's an indicator that you have a very dense population. So that's a good indicator, but also a bad indicator. So they're not able to live for very long off of the chickens because, again, they're obligate parasites and they need the chicken's blood to reproduce. So the current control methods for northern fowl mite include breeding hardier chickens, which takes a long time, and pesticides, which are very effective, but not organic. So we're going to look into the more organic side of things with sulfur dust, kaolin clay, neem oil, diatomaceous earth is DE, and Bovaria is a pathogenic fungi that kill the mites, but not very well, as this Mullen study proved. Sulfur dust is probably the only very effective one out of these treatments, and it's can even eradicate them, and it's pretty long lasting. But over time, it can cause irritation of the eyes and respiratory tract. So we got to find other ways to rotate through different treatments, so we don't have that building up around our chickens. Also looking for organic and other non-pesticide, non-chemical ways for treating pests is important because if we use the same pesticide over and over again, that's how pests start to become resistant to them. So we want to be able to rotate through different types of treatments. So if we found a new one in thyme oil, that would be great. So the potential solution to somewhat poor effective organic treatments and our northern fowl mite on an organic level would be potentially thyme oil, which is what I'm looking at. So northern fowl mites aren't well researched in other countries, but it's a pretty big pest in the US. And preliminary research has tested different essential oils, including cade, garlic, lavender, and lemongrass, and pine. And only cade and thyme were super effective. So that narrows it down a little bit. And then other research from UCR suggested that thyme oil vapors are particularly persistent, which means they last a long time. So that's why we chose to look into thyme oil more. So thyme potentially could be a natural, long-lasting, and effective treatment of northern fowl mite, which is why we want to learn a little bit more about it. Here's a graph from uh, the experiment that looked at all the different essential oils, and you can see cade and thyme were very effective, very fast. With like under 2 hours, they nearly eradicated northern fowl mite as NFM. The mechanism of thyme oil and all these oils is not well understood, so we're going kind of one step at a time, which is why I'm looking at thyme and its volatiles just for the time being, and in the future, hopefully, we'll look more into how it actually affects the mites. But thyme oil, like I said, it's GRAS, which is generally regarded as safe, which is an FDA classification, meaning like you could rub it on your skin even and it would not really harm you, which is fantastic because a lot of pesticides are chemicals that can harm you. So if we could find one that doesn't really harm you and is easy to get a hold of, that would be fantastic. It might be able to be helpful on a large scale, but it would be especially helpful for backyard flocks, like people who have their own chickens just at home. Because right now the method for application is direct, and you have to like spray it on each chicken. But we're also, if we find out that it is effective, we could look into dust bath or dust bag formulations, which chickens naturally like to dust bathe. They like splash dust on themselves, and the dust bag is similar. It's like they run into it and it gets dust on them. But that's generally for like larger livestock. But I thought I'd mention it. So if spraying is really the only application, that wouldn't be great. So that's why we want to look and see if the gas of like the volatiles, like the smells and the whatever the thyme oil is, also effective as just directly applying it. So if it is, we can mix it in with these dust baths, and that would help kill the northern fowl mites, which would be fantastic. So, yeah. So for my experiment, I hypothesized that the presence or persistence of some of these volatile compounds from the thyme oil on these chicken feathers could control the mites, is pretty much what we're looking into. So first we have to identify what's coming off the feathers after we treat them with thyme oil. So in my experiment, here's a picture of it. We're treating these feathers with thyme oil and then kind of blasting air over them and seeing what comes off. And this is after we take the feathers and treat them and then incubate them at 41 degrees Celsius, which is simulating the chicken vent conditions. And the vent is like where the northern fowl mites live. It's kind of like where the eggs come out of the chicken, if you know what I'm saying. So we kind of get the feathers in that kind of condition and see if any microbes or anything make weird gas products. So half of these have the microbes and the other half don't have the microbes because we sterilized them. And then let's see. So yeah, we're going to be doing this with 3 different thyme oil species, and we're going to be using GCMS to analyze the gaseous products. And GCMS is, did I talk about it? Yes, I did. Okay. This diagram shows how it works. Basically, once we blow all the gaseous products into these little glass tubes, I don't know if you can see on the front of the cups, then we can run those through GCMS, which will make them gaseous and then separate them out by mass, and then we can analyze them using mass spec is the other technique. And mass spec tells us like chemical properties and like mass and stuff of the different molecules, and then from there we can identify them, and that's how we're going to identify what kind of volatiles these feathers microbes like to make. So yeah, so progress so far. I actually just got started on this project last week, and this is very exciting. And I finally got funding from the UGR mini grant, which is also fantastic. And so we've already collected the feathers, treated them with the oils, incubated them at 41C, and then run them through this cup setup. And then yeah, we're about to run the filters that we collected. We're gonna run them through the GCMS machine and then see what kind of volatiles come out. So that's very exciting. That's this week. And then yeah, that's kind of it. That's all I got so far. It's very up and coming. So thank you so much to the UGR Center for Undergrad Research and Engaged Learning because they helped fund it. Thank you to Mauck and Murillo Labs who helped do all this setup and come up with this experiment and help me get ready for it and started on it. And then yeah, thank you to everybody who came to listen. Cool. I'm gonna stop the recording here.
Okay.